Namaste dear children, how are you? I am Rekha. Welcome to my channel Rekha's Knowledge Hub. Today we will see NCERT Class 6 Maths Chapter 2 Lines and Angles Part 4. Classifying angles. Angles are classified in three groups as shown below. Right angles are shown in the second group. What could be the common feature of the other two groups? So, angles are generally classified into three groups. We have given a picture. See, right angles are shown in the second group. We have three groups. Then, right angles are shown in the second group. Right angles means they are L-shaped angles 90 degrees. Okay. Then what could be the common feature of the other two groups? We have given two more groups. What about group 1 and group 3? Group 2 are right angles. Then what about group 1 and group 3? We will see. In the first group, all angles are less than a right angle, or in other words, less than a quarter turn. Such angles are called acute angles. So, in the first group, all angles are less than 90 degree. They are less than a right angle, or they are less than a quarter turn. They are called acute angles. See, this is a right angle. See, 90 degree. This is a right angle. This is an L-shaped angle. See this angle. This angle is only 60 degree. This is less than 90 degree. This is less than a right angle. See another angle, 45 degree. This is also less than a right angle. See another angle, 30 degree. This is also less than a right angle. So, these angles are called acute angles. These angles are called acute angles. Acute angles are less than a right angle. In the third group, all angles are greater than a right angle but less than a straight angle. The turning is more than a quarter turn and less than a half turn. Such angles are called obtuse angles. See, this is a right angle, 90 degree angle. We will see some obtuse angles. See, 120 degree angle. This is greater than right angle, greater than 90 degree, but less than a straight angle, but less than 180 degree. So, this is an obtuse angle. Then, see the next angle, angle 170 degree angle. This is greater than a right angle, greater than 90 degree, but less than a straight angle, less than 180 degree. So, these angles are obtuse angles. These angles are obtuse angles. So, now we learn about right angle, obtuse angle and acute angle. Figure it out. Identify acute, right, obtuse and straight angles in the previous figures. See this group? These are acute angles. They are less than 90 degree, less than a right angle. Then, this group is right angles. They are 90 degree angles, L-shaped angles. Then, this group consists of obtuse angles. So, obtuse angles, they are more than a right angle, but less than a straight angle. That is more than 90 degree, but less than 180 degree. They are obtuse angles. Make a few acute angles and a few obtuse angles. Draw them in different orientations. You can draw your own angles. I will show you some examples. See this angle. This angle is 60 degree. This is less than a right angle. So, this is an acute angle. See this angle. This angle is 45 degree. This is less than a right angle. Right angle is 90 degree. So, this is less than a right angle and this is an acute angle. See another angle, 30 degree. This is less than a right angle. This is an acute angle. See this angle is 120 degree. So, this is more than a right angle, but it is less than a straight angle. Right angle is 90 degree. Straight angle is 180 degree. So, this is less than straight angle but more than right angle. So, this is an obtuse angle. Next one, angle 170 degree. This is more than a right angle but less than a straight angle. So, this is also an obtuse angle. Okay. Do you know what the words acute and obtuse mean? Acute means sharp and obtuse means blunt. Why do you think these words have been chosen? The word acute means sharp and is used to describe an angle less than 90 degree appearing sharp, narrow and pointed. So, it is called acute angle. So, the angle less than 90 degrees, they appear sharp, narrow and pointed. So, they are called acute angles. Then what about obtuse angles? The word obtuse means blunt and is used to describe angles greater than 90 degrees and less than 180 degrees, thereby appearing wider and less sharp. Obtuse angles, they appear wider. They are less sharp. So, we use the term obtuse. Find out the number of acute angles in each of the figures below. First figure is given. What are acute angles? Acute angles are less than a right angle. So, we will see how many angles are there in this figure. See, we can mark angles like this. Angle 1, angle 2, then angle 3. There are 3 acute angles. See the next figure. How many angles are there? You mark the angles. See here we got 12 angles. How many triangles are there? There are 4 triangles. So each triangle consists of 3 acute angles. So 4 triangles, 4 threes are 4 into 3, 12. So 12 acute angles are there. Then see the next figure. How many acute angles are there? See there are 21 acute angles. How many triangles are there? There are 7 triangles. Each triangle with 3 acute angles. So, total 7 into 3, 21 acute angles are there. So, number of acute angles is equal to 21. What will be the next figure and how many acute angles will it have? Do you notice any pattern in the numbers? So, what will be the next figure? This is the pattern given. Then, what will be the next figure? See the first pattern, how many triangles are there? 1. In the second figure, how many triangles are there? 1, 2, 3, 4 triangles are there. Then, in the third figure, how many triangles are there? You can see 7 triangles. And how this pattern comes? See in the first figure, you have only 1 triangle. In the next figure, you can see one more triangle and that triangle is drawn inside the first triangle upside down. Okay. Then next figure. In the next figure, one more triangle is drawn inside the second figure upside down. See, this is the pattern. So, what will be the next figure in the pattern? See, like this. You draw one more triangle inside this third figure upside down. You will get the pattern. So here how many triangles are there? Here you will get 10 triangles. So 1, 4, 7, 10. The number of triangles will go like that. 1, 4, 7, 10, etc. Then what about the acute angles? We have seen in the first figure 3 acute angles are there. In second figure 12 acute angles are there. 4 into 3 12. Then in the third figure 7 into 3 21 acute angles are there. Then what about fourth figure? We have 30 10 into 3 30 acute angles are there. Okay. So number of acute angles in the pattern is like this 3, 12, 21, 30. That is increasing by 9. Number of acute angles increasing by 9. Measuring angles. We have seen how to compare two angles. But can we actually quantify how big an angle is using a number without having to compare it to another angle? So, in the last class we have studied how to compare two angles. But we can actually quantify how big an angle is using a number without comparing it with another angle. We see how various angles can be compared using a circle. We have already seen how various angles can be compared using a circle. Perhaps a circle could be used to assign measures for angles. We will see. To assign precise measures to angles, mathematicians came up with an idea. They divided the angle in the center of the circle into 360 equal angles or parts. The angle measure of each of these units is 1 degree, which is written as 1 degree. This unit part is used to assign measure to any angle. The measure of an angle is the number of 1 degree unit parts it contains inside it. So the scientists, they divided the angle in the center of the circle into 360 equal parts. So 1 unit will be 1 degree. So they divided the circle into 360 equal angles or equal parts. So each angle measures 1 degree. So this unit part is used to assign measure to any angle. The measure of an angle is the number of 1 degree unit parts it contains inside it. So you can measure any angle by counting the number of 1 degree unit parts it contains inside it. You have given a picture here. In the first picture, you can see full turn. See, this is full turn, 360 degree. Okay. The angle in the center, it can be divided into 360 equal parts. Each part consists of 1 degree. See this picture. You can see 0 degree, 10 degree, 20 degree, 30 degree, 40 degree. See, it comes up to 360 degree. 0 degree and 360 degree, both in the same line. See, between 0 degree and 10 degree, you have markings like 1 degree, 2 degree, 3 degree, 4 degree, 5 degree, 6 degree, 7 degree, 8 degree, 9 degree. All these markings we cannot show inside this picture. That's why they have shown like this 0 degree, 10 degree, 20 degree, etc. So, here the angle in the center, it is divided into 360 equal parts. Each part consists of 1 degree. For example, see this figure. It contains 30 units of 1 degree angle. So we say that its angle measure is 30 degrees. See, here it is 0 degree and here it is 30 degree. So inside this you can see so many 1 degree units. 1, 2, 3, 4, 5, 6, 7, etc. up to 30. So it contains 30 units of 1 degree angle. So we say that its angle measure is 30 degree. Measures of different angles. What is the measure of a full turn in degrees? As we have taken it to contain 360 degrees, its measure is 360 degree. So a full turn, it contains 360 equal units. So we can measure it as 360 degree. Then what is the measure of a straight angle in degrees? What is a straight angle? A straight angle is half of a full turn. As a full turn is 360 degree, a half turn is 180 degree. So what's the measure of a straight angle? A straight angle is half of a full turn. A full turn is 360 degree. So half turn is 180 degree. Okay. 360 divided by 2, that is 180 degree. Then what is the measure of a right angle in degrees? See, two right angles together form a straight angle. As a straight angle measures 180 degree, a right angle measures 90 degree. So, a straight angle measures 180 degree. Two right angles form a straight angle. So, a right angle measures 180 degree divided by 2, that is 90 degree. See, this is a straight angle. See, how many units are there? 180 units are there. So, this angle measures 180 degree. See, this is a right angle. There are 90 units. So, this right angle measures 90 degree. A pinch of history. A full turn has been divided into 360 degree. Why 360 degree? The reason why we use 360 degree today is not fully known. The division of a circle into 360 parts goes back to ancient times. The Rig Veda, one of the very oldest texts of humanity going back thousands of years, speaks of a wheel with 360 spokes. Many ancient calendars also going back over 3000 years, such as calendars of India, Persia, Babylonia and Egypt, were based on having 360 days in a year. In addition, Babylonian mathematicians frequently used divisions of 60 and 360 due to their use of sexagesimal numbers and counting by 60s. So, this deals with why we use 360. Why we use 360 degree. Perhaps the most important and practical answer for why mathematicians over the years have liked and continue to use 360 degrees is that 360 is the smallest number that can be evenly divided by all numbers up to 10 aside from 7. Thus, one can break up the circle into 1, 2, 3, 4, 5, 6, 8, 9 or 10 equal parts and still have a whole number of degrees in each part. Note that 360 is also evenly divisible by 12, the number of months in a year, and 24, the number of hours in a day. These facts all make the number 360 very useful. So, why we use 360 degree? That is a question. The most important and practical answer is that 360 is the smallest number that can be evenly divided by all numbers up to 10 except 7. So, we can break a circle into 1, 2, 3, 4, 5, 6, 8, 9 or 10 equal parts and still we will get a whole number of degrees in each part. Also, this 360 is evenly divisible by 12. 12 means the number of months in a year, and 24. It is evenly divisible by 24, the number of hours in a day. So, this 360 is a very useful number. The circle has been divided into 1, 2, 3, 4, 5, 6, 8, 9, 10 and 12 part below. What are the degree measures of the resulting angles? Write the degree measures down near the indicated angles. That we will do. So, the circle is divided into 1 part, 2 part, 3 parts, 4 parts, then 5 parts, 6 parts, not 7, then 8. 8 parts, 9 parts, 10 parts and 12 parts. We have to find the degree measures of the resulting angles. And we have to write the degree measures down near the indicated angles. We will do. See the first figure. We can see a full turn here. So, here the circle is divided into a single part. Then, the resulting angle is 360 degree. This is a full turn. So, what is the resulting angle? The resulting angle is 360 degree. See, this angle is 360 degree. Then see the next figure. Here, the circle is divided into two parts. Then, what about the resulting angle? What is this angle? This angle is 180 degree. See, half of a full turn. This is half turn. So, Half of full turn, 360 divided by 2, that is 180 degree. So the resulting angle is 180 degrees. See the next figure. Here a circle is divided into how many parts? 3 parts. 1, 2, 3. So 3 parts. Circle is divided into 3 parts. Then what will be the resulting angle? The resulting angle is 360 divided by 3. That is 120 degree. So this angle is 120 degree. See the next figure. Here a circle is divided into how many parts? 4 parts. Circle is divided into 4 parts. Then what's the resulting angle? Resulting angle is 360 divided by 4. Full turn is 360 degree. So 360 divided by 4. What is the answer? 90 degree. So this angle is 90 degree. Okay. See the figure. Here the circle is divided into how many parts? 1, 2, 3, 4, 5. So the circle is divided into 5 parts. So the resulting angle is 360 divided by 5. What is 360 divided by 5? 72 degree. So the resulting angle is 72 degree. The next one. Here the circle is divided into 6 parts. So what will be the resulting angle? Resulting angle is equal to 360 divided by 6. That is 60 degree. So the resulting angle is 60 degree. Next figure. Here a circle is divided into how many parts? 1, 2, 3, 4, 5, 6, 7, 8. 8 parts. Then what will be the resulting angle? 360 divided by 8. What is the answer? 45 degrees. So the resulting angle is 45 degree. Okay. Then next figure. Here the circle is divided into 1, 2, 3, 4, 5, 6, 7, 8, 9 parts. Okay. Then what will be the resulting angle? 360 divided by 9. That is 40 degree. So the resulting angle is 40 degree. Then see the next figure. Here the circle is divided into how many parts? Check. Here the circle is divided into 10 equal parts. So what will be the resulting angle? 360 divided by 10. That is 36 degree. So the resulting angle is 36. Then next one. Here the circle is divided into 12 equal parts. Then what will be the resulting angle? 360 divided by 12. 30 degrees. So the resulting angle is 30 degree. Degree measures of different angles. How can we measure other angles in degrees? It is for this purpose that we have a tool called a protractor. That is either a circle divided into 360 equal parts or a half circle divided into 180 equal parts. So, to measure angles in degrees, we have a tool called a protractor. This protractor is either a circle divided into 360 equal parts or a half circle divided into 180 equal parts. Unlabelled protractor. Here is a protractor. Do you see the straight angle at the center divided into 180 units of 1 degree? Only part of the lines dividing the straight angles are visible though. Starting from the marking on the rightmost point of the base, there is a long mark for every 10 degree. From every such long mark, there is a medium-sized mark after 5 degree. So, this is an unlabelled protractor. The straight angle at the center divided into 180 units of 1 degree. So, the straight angle at the center divided into how many units? 180 units of 1 degree. Okay. Then Starting from the marking on the rightmost point of the base, there is a long mark for every 10 degree. See, there is 0 degree marking on the rightmost point of the base. From there is a long mark for every 10 degree. For every 10 degree, there is a long mark. See, long mark for 10 degree, then again 10 degree, so 20 degree, then 30 degree, 40 degree, 50 degree, 60 degree, 70 degree, 80 degree, 90 degree. Likewise, it will go up to 180 degree. Okay. Then from every such long mark, there is a medium sized mark after 5 degree. So, after every long mark, there is a medium sized mark. See here. So, this is 5 degree. Okay, this is 5 degree. So, after 10, there is a medium sized mark. It is 10 plus 5, that is 15. Okay. Write the measures of the following angles. Angle KAL. So, this is angle KAL. We have to find the measure of this angle. Notice that the vertex of this angle coincides with the center of the protractor. So, what is the vertex of angle KAL? It is A. So, A must coincide with the center of the protractor. So, the number of units of 1 degree angle between KA and AL gives a measure of angle KAL. So, we have to count the number of units of 1 degree angle between KA and AL. See, between any two large sized marks, there are 10 units of 1 degree angle. So, here, up to here, we have 10 degree. Then, here, again, a large sized mark. So, here, 20. Then again one more large sized mark, so 30 degree. So the measure of angle KAL is 30 degree. Then making use of the medium sized and large sized marks, is it possible to count the number of units in 5s or 10s? Yes, it is possible. We had done in the same way. Then next we have to find the angle WAL, which is angle WAL. See, this is WAL. This is angle WAL. So, to find the measure of angle WAL, we have to count the number of units of 1 degree angle between WA and AL. Okay, we have to count the number of units of 1 degree angle between WA and AL. So, between any two long sized or large sized marks, there are 10 units of 1 degree angle. So, here we have 10, then 20, here 20, then 30, then 40, here, then 50. So, what is the measure of angle WAL? It is 50 degree. Similarly, find the measure of angle TAK. So, angle TAK. So, this is angle TAK. Okay. So, to find angle TAK, we have to find the number of units of 1 degree angle between TA and KA. See here. See the long sized marks or large sized marks. So, 10, 20, 30, then 40, 50, 60, 70, 80, 90, then 100, 110, 120. So, angle TAK is equal to 120 degree. Okay. So, this is same as the sum of angles KAL plus WAL plus WAT, that is 40 degree plus 50 degree plus 30 degree equal to 120 degree. Next one, labeled protractor. This is a protractor that you find in your geometry box. It would appear similar to the protractor above, except that there are numbers written on it. Will these make it easier to read the angles? Yes, definitely. So, in labeled protractor, there are numbers written on it. See, you can see the picture here. There are two sets of numbers on the protractor. One increasing from right to left and the other increasing from left to right. See, we can see two sets of numbers on the protractor. One increasing from right to left. See, 0, 10, 20, 30, 40, 50, likewise up to 180. Increasing from right to left. And the other increasing from left to right. See, we can see 10, 20, 0, 10, 20, 30, 40, 50, up to 180 here. So, this is increasing from left to right. So, we have two sets of numbers here. Why does it include two sets of numbers? This is for convenience in lining up angles regardless of the direction of the angle. This is for convenience. We can easily measure the angle irrespective of the direction of the angle. Name the different angles in the figure and write their measures. See, first we will see the angle QOP. So, you start from 0 here. So, 0, 10, then 20, 30. Then the ray passes between 40 and 30. See, through the medium sized mark. So, 30 plus 5, that is 35. So, angle QOP is 35. Then we will see some other angles. See, angle. Next we have angle ROP. See, this is angle ROP. So, you start from the rightmost side. 0, 10, 20, 30, 40, 50, 60, then 70, 80, 90. Then the ray passes through the medium sized mark. So, 90 plus 5, that is 95. So, angle ROP is equal to 95 degree. Then we have angle SOP. See, this is angle SOP. SOP. Then what is the measure of that angle? See, you start from the rightmost side. So, 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. Then 100, 110, 120. Then the ray passes through the medium sized mark between 120 and 130. So, add plus 5. So, 125. So, angle SOP is equal to 125. The next we have angle TOP. See, this is angle TOP. Then, what is the measure of this angle? You start from rightmost side and check from 0, 10, 20, 30 up to, see, the ray passes through 160. See, 160. So, the measure of this angle is 160. Then next, we have angle UOP. This is angle UOP. See, this is angle UOP. What will be UOP? It is a straight angle. So, it is 180 degree. So, these are some of the angles in the figure. Did you include angles such as TOQ? We will include. Which set of markings did you use, inner or outer? What is the measure of angle TOS? All these we will do. See, we have to find the angle TOQ. See, this is angle TOQ. We have to find the measure of this angle. So, you start from the leftmost side, that is from you start. Then, you check the reading at Q. What's the reading at Q? It is 145 degree. So what is angle TOQ? Angle TOQ equal to 145 degree minus, you have to subtract this much readings here between U and T. The angle UOT is 20 degree. So you have to subtract 20 degree from 145 degree. So what will be the angle? 145 degree minus 20 degree, that is 125 degree. That is angle TOQ is equal to 125 degree. Which set of markings did you use, inner or outer? Outer markings. What is a measure of angle TOS? Can you see the numbers marked to find the angle without counting the number of markings? Yes. So we have to find angle TOS here, which is angle TOS. See, this is angle TOS. See, this is TOS. Okay. Here OT, this is OT, and OS, this is OS. Pass through the numbers. 20 here, see, we can see 20 here, 20 and 55. See, on the outer scale, how many units of 1 degree are contained between these two arms? Can subtraction be used here? So how many units of 1 degree are there between the numbers 20 and 55? We have to subtract 55 minus 20, that is 35. So this angle TOS is 35 degree. How can we measure angles directly without having to subtract? Place a protractor. So the center is on the vertex of the angle. So without subtracting, how we can measure angles directly? For this, place a protractor in such a way that the center is on the vertex of the angle. Center must be on the vertex of the angle. Align the protractor so that one of the arms passes through the 0 degree mark as in the picture below. So you have to align the protractor in such a way that one of the arms passes through 0 degree. See, passes through 0 degree mark. So what is the degree measure of angle AOB? What is angle AOB? See, one of the arms aligned through 0 degree. So angle AOB is equal to, see here, check the reading. What is it? 80 degree. 0, 10, 20, 30, 40, 50, 60, 70, 80. This is 80 degree. We can directly read from this point 80 degree. So this angle is 80 degree. Make your own protractor. You may have wondered how the different equally spaced markings are made on a protractor. We will now see how we can make some of them. So first step, draw a circle of a convenient radius on a sheet of paper. So first you draw a circle of convenient radius on a sheet of paper. Then cut out the circle. A circle or one full turn is 360 degree. So you cut out that circle. So this is 360 degree. Then fold the circle to get two equal halves. You fold in such a way that you will get two equal halves and cut it through the crease to get a semicircle. Now you will get a semicircle. Write 0 degree in the bottom right corner of the semicircle. Here you write 0 degree. Okay. The measure of half a circle is half of a full turn. What is full turn? Full turn is 360 degree. So half of a full turn is how much? 180 degree. So the measure of half of a turn is equal to half of 360 degree, that is 180 degree. Thus write 180 in the left bottom corner of the semicircle. See, left bottom corner you write 180 degree and the right bottom corner you write 0 degree. See, now we have 180 units of 1 degree angle here. What is the next step? Fold the semicircular sheet in half to form a quarter circle. So you have to fold this semicircular sheet in half to form a quarter circle. The measure of a quarter circle is 1 by 4 of a full turn. What is full turn? Full turn is 360 degree. So the measure of a 1 by 4 turn is equal to 1 by 4 of 360 degree. 1 by 4 of full turn, that is 1 by 4 of 360 is equal to how much? 90 degree. Or the measure of a 1 by 4 turn is equal to half of a half turn. That is half of 180 degree. That is equal to 90 degree. Thus mark 90 degree at the top of the semicircle. See, mark here 90 degree. You mark at the top of the semicircle. So up to here we have 90 units of 1 degree angle. Fold the sheet again. So again fold the sheet. Now what you will get? When folded, this is 1 by 8 of the circle. That is 1 by 8 of a turn or 1 by 8 of 360 degree. In other words, it is 1 by 4 of straight angle, that is 1 by 4 of half turn, that is 180 degree, or half of 90 degree or half of quarter turn, that is 45 degree. The new creases formed gives us measures of 45 degree and 180 degree minus 45 degree is equal to 135 degree as shown. So here you will get 45 degree and here you will get 135 degree, that is 180 minus 45 degree or 90 degree plus 45 degree. So you will get 135 degree. Write 45 degree and 135 degree at the correct places on the new creases along the edges of the semicircle. So continuing with another half fold, we get an angle of measure. See, here we have 0 degree and here we have 45 degree. So again half fold. So what will be the measure here? 45 degree. Half of 45 degree, that is 22.5 degree. So here you have 22.5 degree. Unfold and mark the creases as OB, OC, etc. as shown in figure. See, you unfold and mark the creases like this. So here 22.5. So here 180 minus 22.5, that is 157.5 degree. Okay. See the figures. Here we have angle AOB is equal to angle BOC is equal to angle COD is equal to angle DOE is equal to angle EOF is equal to angle FOG is equal to angle GOH is equal to angle HOI is equal to 22.5 degree. Why? 180 degree divided by 8. We have 8 equal parts. So 180 degree divided by 8 is equal to 22.5 degree. Okay. Next one, angle bisector. At each step, we folded in halves. This process of getting half of a given angle is called bisecting the angle. So what is bisecting the angle? The process of getting half of a given angle. It is called the bisecting the angle. The line that bisects a given angle is called the angle bisector of the angle. So a line that bisects a given angle is called the angle bisector of the angle. Children, thanks for watching. If you like this video, please like, share and subscribe. We will see in the next video. Thank you.